Yes, sir.
Okay. So in the previous class, just wait a minute, where it is. In the previous class, we discussed about the SN1 and SN2, right? Today we are going to start elimination reaction. Today we are going to start elimination reaction. What is elimination reaction? This reaction is also known as beta elimination reaction. Beta elimination reaction, or we can also call it dehydrohalogenation. Dehydrohalogenation. Basically, D, whenever there will be a prefix D, that means you are going to remove hydro, that is a stand for hydrogen, and halogen, that is HX. So if you are going to remove HX, there will be formation of alkene, and this is known as beta elimination. Why it is beta elimination? I'm gonna tell you. So this is your X, and this is your hydrogen, and this is X. If you are going to carry this reaction in alcoholic KOH, and you are going to heat it, so see what will happen. To the carbon, X is connected. X is connected to the carbon. That carbon is known as alpha carbon, and the carbon which is directly attached to the alpha carbon is known as beta carbon, and the hydrogen which is connected with beta carbon is known as beta hydrogen. So what you need to do, just remove X from alpha and hydrogen from beta, and make a pi bond, make a double bond between these two. This is known as elimination reaction. There may be more than one product possible if beta hydrogen is more than one type of, if there is more than one type of beta hydrogen is. Just like if I'm gonna show you, see, this is your X, and if you are going to carry this reaction in the presence of alcoholic KOH, you can see this is your alpha, so beta carbon is here and beta carbon is here. Beta carbon we don't need to deal with, but we need beta hydrogen, and beta hydrogen comes from beta carbon. So if you are going to remove hydrogen from here, you will be getting a double bond between this carbon and this carbon, and it will be like this. And you can see if you are going to remove hydrogen from here and X from here, X is fixed. So you will be getting this product. So this is known as your butene, and this is known as but1ene, but2ene. So basically, which one is major and which one is minor? So this will be your major and this will be your minor. Always remember how you are going to decide it. The more alkylated alkene, more stable or major product. You can see it has two alkyl group, but this has only one alkyl group, so it is less stable, or this is more stable, or either you can go through alpha hydrogen. This has 6 alpha hydrogen and this has only 2 alpha hydrogen, so this is more stable. That's why it is major. Is that clear?
Yes, sir.
Okay. Can I change the slide?
Yes, sir.
Okay. Now the next type of reaction I told you is about the reaction with metal. Reaction with metals. So you already are aware of this reaction with metal, in which the first is Wood's reaction. Wood's reaction. What does Wood's reaction say? See, if Rx is, if you are going to treat this aldehyde with sodium in the presence of dry ether, you will be getting R. How the reaction took place? You are going to take 2 moles of this and 2 moles of this, and I'm going to write another mole of this in this term, like this, and just remove this salt and add this RR, you will be getting RR. So all I want to say is that from Wood's reaction, odd number electron is not possible. Odd number carbon production is not possible. And also you cannot prepare methane. So as you can see, if there is one carbon, you will be getting ethane. If there is two carbon, you will getting butane, but you cannot get an a hydrocarbon which is having only odd number of carbon. You will always get Samira and a.
Yes, sir.
Now the next is fatigue reaction. Fatigue reaction. Fatigue reaction is for arenes, haloarenes. What you need to do? Treat this haloarene with sodium in the presence of dry ether. What you need to do? Just double it. Just double it. This is your biphenyl. Biphenyl you will get. Then comes your the next Woods fatigue. You can see Woods is for alkane, fatigue is for arene, that is benzene, and Woods fatigue is for both. You are going to add this both. Like this is your fatigue haloarenes, and you are going to treat this with sodium and react this with alkyl halide. Haloarene reacting with alkyl halide. So what you need to remove, it's very simple. You are going to remove this. Just wait a minute. You are going to remove this. Na is here. X, I'm going to write it like this. And you are going to remove this NaX and add this. So this is known as Woods fatigue reaction. And this is your byproduct. So reaction with metal is quite easy in this chapter. And this chapter is completed. With the reaction Grignard, we will deal with this. Let me know when you are done with this. Are you done with this?
Yes, sir. Done.
No.
Yes, sir.
The last reaction I'm going to give you is reaction with metal. It is also known as, basically, if you are going to react Rx first with Mg, you will be getting RMgX. This compound is also known as organometallic compound. Organometallic compound. And this reagent, this has a name, which is a reagent, and its name is Grignard reagent. And it is very, very reactive. Two reactivities. Very reactive. If you are going to react this Grignard, or if Grignard comes in contact with moisture, it will directly convert itself into hydrocarbon. How? You can see water has two parts, H plus and OH minus. And also you can see X will have negative vitamin. R, which is more electronegative than magnesium. Magnesium is a metal, so this will have plus, this will have minus. So this will go with this and it will convert itself into hydrocarbon. Hydrocarbon. And this will be your byproduct. This negative will go to this and it forms MgOH. So this is your byproduct. Grignard is so reactive that it will convert itself into hydrocarbon if even it comes in contact with moisture. Is that clear?
Yes, sir.
Okay. So can I change the slide?
Yes, sir.
Okay, let me know if you are able to see a new screen. I'm going to give you some questions, then we will start alcohols. Are you able to see a new screen?
Yes, sir.
Okay, so you are going to do question number 1, 2. First, you are going to do these two questions. Very good. Okay, Samira. Very good. Iram, this is for first question or the second? It's wrong. No, it's wrong. First one is for D will be the answer. Elimination reaction of 2-bromopentane to form pen-2E. You can see 2-bromopentane. I'm going to write here. There will be two products from here. One is this and another is this. This is the major product. You can see this reaction is known as beta elimination. Follow Jetsev rule. Jetsev rule, that means more alkylated part is major product, and then dehydrohalogenation reaction it is. Dehydration, that means removal of water. So that's why D is the correct answer. What is for the second answer? Yeah, it is good. Which of the following alkane cannot be made in gold by Woods? Woods reaction cannot form or prepare CH4 methane and odd number of carbon. So you can see N-heptane, which has 7 carbon, which is odd, so it is not possible. Is that clear, everyone?
Yes, sir.
Question number 7. It is about SN1 and SN2. One means A, Alia. 7I, you have written. What does this mean? Okay, that's good. Always keep it in mind that SN1, SN2. SN1 can occur in weak nucleophile, and for this we need a strong nucleophile. So as you can see, C2H5OH, in which lone pair is there, and here negative charge. Negative charge, that means a strong nucleophile, and this is your weak nucleophile. That's why the first one is SN1 and the second one is SN2. Is that clear? These are some points that you need to remember and you need to take care of. Okay.
Yes, sir.
Okay. Question number 9. Which of the following reaction is an example of nucleophilic substitution reaction? That means nucleophile is substituting. Any ninth one? Substitution reaction. See, this is not a nucleophilic substitution reaction. Since nucleophile is not there, this is also not. But if you are going to look at this, Rx is connected with KOH. Here, OH minus and K plus. And as you can see, this OH minus is going with R. Are you able to see the screen?
Yes, sir.
So in this reaction, you can see with this, a nucleophile forms OH minus, which will attack R and it will form ROH. So the best example is B. Nucleophilic substitution reaction, that means nucleophile will substitute. So OH minus is a nucleophile. Is that clear?
Yes, sir.
The last question 14. Please do. C is the wrong answer. A is the correct answer. Best living group, you can see I minus, then Br minus and Cl minus. Or you can go for like this, down the group, nucleophilicity increases because the size of an ion also increases, and the last electron, the distance between last electron and the nucleus increases, force of attraction decreases, so it can easily donate. That's why I minus is the best, then Br minus, then Cl minus. Okay. Can I change the slide?
Yes, sir.
Okay. Now I'm going to share the screen. Let me know if you are able to see the screen. New screen, black. And we are going to start this chapter. Are you able to see the screen?
Yes, sir.
Okay, let me know. As we have studied in the previous class, just let me know whether which one is allylic alcohol and which one is vinylic alcohol. This is your A and this is your B, and you are going to tell me which one is allylic and which one is vinylic alcohol.
Sir, first
First one is what? A is allylic and this is your vinylic alcohol. As we already discussed in the previous chapter, allylic halide and vinylic halide, in which we came to know about this. To the carbon that OH is connected is sp3 should be sp3 and adjacent carbon should be doubly bonded, that is allylic. And since OH is connected, so allylic alcohol. And to the carbon OH is connected, this should be sp2, so that is vinylic. And since OH is connected, so it is known as vinylic alcohol. Also, you can divide this, as you can see, if I'm going to write this CH3 CH2 OH, you know, this is your what? Primary, secondary, tertiary. Can you divide this? Classify this. So the first one, if you are looking at, you can see this will be your primary alcohol. This will be your secondary alcohol. And this will be your tertiary alcohol. If anyone have any doubt, just ask me. This is the right time. As you can see, to the carbon X OH is connected. This is 1 degree. That's why it is 1 degree alcohol. To the carbon OH is connected. This is your 2 degree. And that's why it is secondary. And to the carbon OH is connected. This is your 3 degree. That's why it is tertiary. So these are basic classification. You can also classify in the on the basis of number of alcohol group. Like if one OH is there, monohydric, two OH is there, dihydric, trihydric, and phenol. You can also classify in the same way. Okay. Can you change the slide? Samara, Iram, Abhinav, Anna,
Yes.
can I change the slide? Okay. Now moving to the next part for MOP, that is methods of preparation. Have you studied about this, the method of preparation? Yes or no? Have you revised it? Yes or no? Samaira, Iram, Alia, Anna, Avino?
Yes, sir.
Okay. If you have revised, so I'm just gonna give you a little bit hints. MOP from alkenes. From alkenes. So I'm just going to start with very basic. I'm gonna give you ethene. And if you are going to treat this ethene, just wait a minute. If you are going to react this with water in the presence of acid H plus, what will be the product? And if you are going to treat this with H2O, what in the presence of acid, what will be the product? Just let me know the name
Sir,
of the product.
first one is
First one
ethanol.
is,
Ethanol.
can you repeat? Yeah, it is ethanol. So what you just, what did you just do? H plus and OH minus is there. And here we follow Markovnikov. In here we follow Markovnikov. And what does Markovnikov says? It's very important to know that negative part will go to that carbon across double bond, which has lesser number of hydrogen, and positive part to that carbon, which has greater number of hydrogen. But in here, ethene is a symmetrical alkene. It doesn't affect. Either you are going to add H plus to the left or right, it won't affect, and it will be CH3 or CH2OH. I'm gonna write and CH2OH. So this is your ethanol. Since it is a symmetrical, so it won't affect. But when we have a symmetrical alkene, we are going to apply Markovnikov, and it will help you to do the product. Please do the B or C.
The second one is propane 2-ol.
That's great. You can see this has two parts, H plus and OH minus. OH minus will go to that carbon which has greater number of, a lesser number of hydrogen. So this will be the product propane 2-ol. Can anyone tell me about the C?
Sir, 3-methyl butane 2-ol.
3-methyl butane 2-ol. Okay. So This is a very good question, and this question will clear your all doubt. Actually, if you have revised in the formation of alcohol from alkene, in the mechanism, if you have seen, formation of carbocation took place. Formation of carbocation takes place. And whenever in mechanism or in any reaction, formation of carbocation takes place, then rearrange if possible. Then rearrange if possible. If possible. So everywhere formation of carbocation took place. There was no need of that. That's why I didn't explain. But here you can see formation of carbocation takes place can be here, and formation of carbocation takes place can be here across double bond. But you know that this is less stable 1 degree, so we won't gonna talk about this. We are going to talk about this only. So whenever formation of carbocation takes place, you can see you need to look adjacent to this carbocation. If you are going to move this 1 degree, which is lesser stable than this, so we are not going to move on the right hand side. But if you are going to, am I audible? If you are going
Yes.
to move to the right hand side, you can see this carbocation can be 1,2 hydride safe if you are going to do. Then this carbocation can be tertiary. Now it is more stable, and hence now OH minus come into play and it will attack here, and you will be getting a product that has a name 2-methyl butane 2-ol. Are you getting my point?
Yes, sir.
So this is very important. You have to be clear about the formation of carbocation. Whenever formation of carbocation takes place, you are going to rearrange if possible. Okay. Can you change the slide?
Yes, sir.
Now the next preparation that comes is your hydroboration oxidation. Hydroboration oxidation. So hydroboration oxidation, as you can see, this follows anti-Markovnikov. This follows anti-Markovnikov. And what is anti-Markovnikov? You know that negative part go to that carbon which has greater number of hydrogens. How you are going to recognize? This is also from alkene. So if you have RCH double bond CH2, and if your reagent is borane, that is BH3 in the presence of THF, tetrahydrofuran, and at the second position you and in the second step, basically hydrogen peroxide in the presence of base, in the presence of base. So there will be there will be H plus and OH minus. There will be H plus and OH minus. OH minus from here and H plus from here, you can see. So positive, negative part will go to that carbon which has greater number of hydrogen, and this will go to this. So you will be getting a primary alkyl. So first you need to recognize the reaction, where which reaction is what. Like if you have given an alkene with water and in the presence of acid, that means it is acid catalyzation of acid catalyzed reaction of alkene. That means Markovnikov will follow, and formation of carbocation takes place. So if rearrangement is possible, then you can do hydroboration reaction, hydroboration oxidation. If you have given an alkene in the presence of BH3 H2O2 in the presence of this, so you are going to do anti-Markovnikov. So these are very easy questions. Is that clear? Can I change the slide?
Yes, sir.
Now the next is preparation from carbonyl compound, and in this first preparation is gonna from by reduction of aldehyde and ketones. See, first we are going to have this reaction by reduction of aldehyde and ketones. This is a reducing agent. A reducing agent. Either you can use this reducing agent, what we call sodium boron hydride, or either you can use LiAlH4, and either you can use H2 in the presence of palladium. H2 in the presence of palladium or nickel, you can use this. First of all, the first and third one is mild reducing agent. Mild reducing agent. And this one is a strong reducing agent. In the same way, you can use here as well. See how the reaction will take place. First, if you are going to react this, bond between oxygen and carbon will be broken. Hydrogen will be added to the carbon and oxygen, and you will be getting a product RCH2. And you can see the next is C, which is connected with H, and with the reagent, it becomes CH2 and now OH. And again, if you are going to do the same H and H here, by breaking the bond between carbon double bond oxygen, only one bond between carbon oxygen. So there will be a product that's CH3, CH2, and then COH it becomes, and then H is there and CH3. So this is a very important point to remember, that if you are going to reduce an aldehyde, you will be getting 1 degree alcohol. You will be getting 1 degree alcohol. And if you are going to reduce ketone, you will be getting 2 degree alcohol. This is very important. And vice versa. If you are reducing aldehyde, you are getting 1 degree alcohol. That means if you will oxidize 1 degree alcohol, then you will be getting aldehyde. And if you are going to oxidize 2 degree alcohol, you will be getting ketone. So this oxidation we will be studying in the chemical reaction of alcohol. Please do write it and then let me know. Can you change the slide? Just let me know. Are you done with this?
Yes, sir.
Okay. Now see, from carbonyl compounds now, by reduction of carboxylic acid and esters. So if you are going to reduce a carboxylic acid and trying to reduce with NaBH4, or either you are going to reduce an ester with NaBH4, this will not work because it is a mild reducing agent. For this, you need to reduce it with a strong reducing agent like LiAlH4. LiAlH4. This, and according to this, you are going to see this will be removed. Bond between carbon and oxygen will be broken and hydrogen will be added. Now you can see RCOH, H is there and OH is there. Now always remember that 2OH group on carbon is not stable. So you are going to remove this water. Oh, wait a minute, I just did it wrong. Then carboxylic acid will not, aldehyde will form, and then again carboxylic acid will form. Wait a minute, why we should go this much lengthier? Always remember that when you are going to use an strong reducing agent, what you need to do, just convert this aldehyde into, sorry, convert this carboxylic acid into alcohol. What you need to do, just break this both bond. For both first bond, H and H will be added here. For second bond, H and H will be added here. Now you can see this will reduce RCH2 directly converted into 1° alcohol. Again, if you are going to do the same, H and H will be first. What you need to do, just break this bond, H and H will be added here, and break one of the bond between carbon oxygen, H and H will be added here. So what you will be getting, you will be getting RCH2OH and again R-OH. For this R-OH, and you can see the rest part is RCH2OH. In this way, we can prepare alcohol from carboxylic acid and ester as well. So one thing that you need to take care is that from aldehyde, you are getting 1° alcohol. From ketone, you are getting 2° alcohol. From carboxylic acid, you are getting 1° alcohol. And in this, that depends upon the alkyl group. For ester, that depends upon the alkyl group. Please do let me know when you are done with this. Are you done with this?
Yes, sir.
No. Now see, I'm gonna give you a question, just checking that how much you have done. Just wait a minute. If I'm gonna give you. See, are you done with this? Now you have to recognize this functional group. This is your ketone and this is your carboxylic acid. Okay. And NaBH4 is a mild reducing agent. It cannot reduce carboxylic acid, but it can reduce the ketone. So ketone will be reduced to alcohol, but the rest part will be as it is because it cannot reduce carboxylic acid. To reduce this ester, you can see hydrogen will be added here, and again hydrogen and hydrogen will be added here. So this is what you will get, CH3 CH2OH, and then this is cyclopentanol. This is, so it's very easy, I think. Let me know when you are done with this. Are you done with this? Alia.
Yes, sir. Yes, sir.
Now from Grignard, and this is one of the most important reactions. And let me know if you will be able to do it or not. HC double bond O. First, you are going to react this with RMGX, and after that, you will get a product, and then you are going to treat that with H2. Then the next is RC double bond OH. This is also an aldehyde. First, you are going to react this with RMGX again, and in the second step, you are going to do the hydrolysis. And then again RC double bond O, that is your ketone. First, you are going to react this with R-MGX. You can take RMGX as well. Just let me know, will you be able to solve it? Yes or no? If you are not able to solve it, just let me know. And if you can, then let me know. Very good, Alia. Very good. Alia next. We know, are you able to solve this or not? The second one is RCHOH. Okay, Samara, you have sent me with something else. Okay, let me explain. First of all, this is methanol, which is a member of an aldehyde. the first member. This will have negative, this will have positive. And as you can see, oxygen is more electronegative. So it will have negative and this will be. Now this negative will be attacking here and positive will be going. So what you will get, that is important. First of all, I'm going to write C, and with C, 2 hydrogen is there. And as you can see, this R is going to attack on this, so it will make bond with it. And you can see oxygen is there, which will have negative sign because it took electron from carbon. And then comes Mg plus and X. After this, you are going to treat this with H2O. That means this H2O has two parts, H plus and OH minus. So this H plus will go with oxygen and OH minus will go with this. So what you will get RCH2 OH plus. This byproduct will be similar in all the cases. So I'm not going to write for all the time the byproduct. So that means with methanol, you will be getting 1 degree alcohol. 1 degree alcohol. Now again, similar case will be here, negative, positive. This will be attacking here and this positive will be attacking here. So what you will get, it's very important. You can see R and with C, H is there. And you can see on this carbon, R is attacking, so R, and this will have O negative and Mg positive X. This is your G and this is your X. Now again, you are going to treat this with H2O. That means H plus and OH minus. Now you know that what will happen. This H plus will go with this, and now you can see RCH, and with CH, OH is there, and one R is connected with CH. So that means you are getting 2 degree alcohol. Now you can see the third reaction, that is very important. Third reaction, this will be negative, this will be positive. Again, this will have negative, this will have positive. So this will go like this. And RC, there will R come R, and then O negative, and then Mg plus X minus X. And you are going to treat this with H2O. That means H plus and OH minus. Again, the same process. H plus will go to this, and what you will get, R dash is there. R, C, R dash, and R, and then comes your OH. What I want to say is that when Grignard reagent is going to react with any aldehyde except this methanol, you will be getting 2 degree alcohol. Again, I am going to repeat. When Grignard reagent is going to react with any aldehyde except methanol, you will get 2 degree alcohol. And when Grignard reagent react with methanol, you will get 1 degree alcohol. And when Grignard reagent react with ketone, you will be getting 3 degree alcohol. Is that clear? All of you?
Yes, sir.
Okay. Can I change the slide? Just let me know when to change the slide.
Done, sir.
Very good. Now see the chemical reactions. Before starting chemical reaction, always remember that alcohol can act as nucleophile and it can act as electrophile. But for electrophile, there is a condition. Only protonated alcohol do this. Only protonated alcohol react as electrophile. Protonated alcohol, that means if you have an alcohol, first you need to react this with H plus. This is your proton. So this will attack here, and now it becomes protonated alcohol. Protonated alcohol. Only protonated alcohol react in this manner, but all alcohol can react as nucleophile. That means you know that there will be donation of electron. It will donate electron. Is that clear? Yes or no? Is that clear? Iram, Samaira, Alia, Abhinav, Anna.
Yes, sir.
Okay. Now we are going to start this acidity of alcohol. Acidity of alcohols. So it's very easy. First of all, from class 10th, you have studied that when acid and base react, what will form? Salt plus water. Salt plus water. And when acid plus metal react, what will form? Salt plus hydrogen gas. Salt plus hydrogen gas. In this way, you can see if this is an alcohol, let's take CH3, CH2, OH, and you are going to react this with a metal, then what will happen? You can see there is the formation of salt and hydrogen gas. This is your acid, this is your metal, so this is what it forms. Now, phenols also react in the same manner. Phenols also react in same manner. That means basically if you have phenol like this, you can see, and you are going to react this sodium, what will happen? A phenoxide ion will form, which is a salt, and hydrogen gas will be equal. You can balance it by your own. So this is known as sodium alkoxide or sodium ethoxide, we can say, because ethyl group is there. So I'm going to write sodium ethoxide, and this is your sodium phenoxide, which is a salt. Is that clear? So it's very easy. Just let me know when you're done with this.
Done, sir.
Okay. Now see, as you know that acidic strength directly proportional to minus I, directly proportional to minus N, inversely proportional to plus I, and inversely proportional to plus I. So I'm going to give you a very easy question. This is your tertiary alcohol that I'm going to give you. This is your secondary alcohol. And this is your primary alcohol. Arrange them in decreasing order of acidic character. Arrange them in decreasing order of what do you think? Which one will be the most acidic? Any answer from anyone of you? See, I'm going to explain. You know that R is an alkyl group. If you remember in GOC, I told you that this alkyl group by default has plus I effect, and plus I effect is inversely proportional to acidic strength. In tertiary alcohol, this carbon is getting from three sides plus I. That means it is decreasing its acidic strength. This is getting from two sides and this is getting from one side. So this will be the acidic character. CDA. Is that clear?
Yes, sir.
Okay. Acidity of phenols we can also compare in the same way. So if I'm gonna give you, this is a phenol, as you can see. This is your 4-methyl phenol or para-methyl phenol, and this is your para-nitrophenol. Just arrange them in increasing or decreasing order of acidic strength A, B, and C. Will you be able to do this? Are you able to solve this or not? We know very good. Who gives the answer? Anna. Very good. You can. This is NO2. Sorry. NO2 has minus M effect and minus I effect. CH3 has plus I effect. So this decreases its acidic character. At least plus I decreases. So at least there is no one to decrease and no one to increase. So it will be constant. So C will be the most, then A, then B. Iram and Samaira, Alia, are you not able to understand this? Got it, sir. Okay. Now I'm gonna show you esterification reaction. Esterification. You have studied this in class 10th as well. When carboxylic acid react with alcohol in the presence of acid, then a sweet smelling compound is formed, substance is formed, that is basically an ester. That is ester. So either you can use on alcohols and phenols. I'm going to write this point. React with either carboxylic acid, either it can react with acid anhydride to form ester. Either it can also react with acid anhydride is there. Wait a minute. Acid halide, acyl halide or acid halide, you can call it. With phenols or alcohols, it will give what ester. So this is your acid anhydride. You can see. I'm going to show you the reaction. See, this is your first. This is your ethanol, and you are going to react this with first carboxylic acid in the presence of an acid, and this is reversible reaction. So what will happen? You are going to remove this H2. You are going to remove this H2O, and you will be getting CH3CH2O and then C double bond O and CH. This is what ester. This is ester which has a name, ethyl ethanoate. Ethyl ethanoate. Its name is basically end with OA, and you can see you have two alkyl group here and here. You need to decide one of them will be parent and one of them will be substituent. Since both have same, so you can take any one of them as alkyl. So its name is basically alkyl alkanoate. Just suppose if the parent chain has 3 carbons, so its name will be propanoate. Is that clear?
Yes, sir.
Okay. So I'm going to show you a very important reaction from NCERT, and that is, this is your, what we say, this is your phenol, and here it is your carboxylic acid. And if you are going to react this with acyl halide, CH3C double bond OCl, in the presence of pyridine, what will happen? I'm going to show you. This is your chlorine and this is your hydrogen that will combine together and it will be eliminated. So what you will get basically as a byproduct HCl, and you can see the OH is as it is. Then there was C double bond O, then there was O, and this O will be directly connecting with this C. Oh, wait a minute. Just wait a minute. I just did a mistake because I told you that alcohol or phenol react with acyl halide, acid anhydride, or what? There was 3 compounds. Alcohol react with carboxylic acid, acid anhydride, and acyl halide to form ester. And I was doing mistake, acyl halide reacting with carboxylic acid. I'm going to remove this part. So what you will be getting, just wait a minute, I'm going to show you. HCl will be as a byproduct, and then this part will be converted into O, then C double bond O and CH3 is there, and then this is your C double OH. In NCERT, it has been written like this, C double OH, and as a name, its common name is aspirin, which is a very important compound. Please do write it, and if this has a name, you will see it, salicylic acid. So we were studying the chemical reaction of the alcohol in which OH bond is cleaved. Now we are going to study about the COH. We will study about this. Please do let me know when you are done with this. Instead of doing this, I'm gonna give you some question of this chapter as well. Just let me know when you are done with that. Are you done with that? Iram, Alia, Samira, Anna.
Yes, sir.
Okay. So you are going to do question number 6. Alia, what about your board paper? How was it? How much you are expecting? Please do question number 6. Okay, don't worry, everything will be fine. You have done it correctly. Nice. Has anyone got the answer? Anna, Iram, Samira, any answer? Alia. See, I'm gonna explain this. CH3 there, KCN is there. So CN minus is there, then nucleophilic substitution reaction takes place, and you will be getting this methyl nitriles. And whenever you are going to hydrolyze this methyl nitriles, then this cyanide or nitriles will be directly converted into carboxylic acid, CH3COOH. And if you are going to use LiAlH4, as you know, this is a strong reducing agent. Very good. This is a strong reducing agent. Then it will be directly converted into alcohol, which is ethyl alcohol. Isn't it easy? Very good. CH3OH. No. CH3CH2OH. No, it will be. Right, Alia? Okay. Iram, Samira, everyone got this?
No, sir.
Yes.
Okay. If you have any doubt, you can ask me. Question number 8. I'm just gonna erase this part. Question number 8. Very easy question. Oh, please do it. Question number 8. Tamara, will you be able to solve this? See, I'm gonna explain. Ethanol, this is your CH3, CH2, OH reacting with PBr3. In the previous chapter, formation or preparation of alkyl halide from alcohol. Then what you will be getting? CH3, CH2, OH will be replaced by Br. That means bromoethane you have got. After bromoethane, you are going to treat this with alcoholic KOH, elimination reaction. Br from here, H from here. That means you will be getting CH2 double bond CH2. Alkene you have got. Now, what you are going to use, you can see, you are going to hydrolyze it. That means reaction with water in the presence of acid. So what you are going to do is the same reaction. Markovnikov will follow. This bond will be broken and H will be added to one of the carbons. Since it is symmetrical alkene, you can use any one of them at any place, H or OH. So the answer is C, that is ethanol. Is that clear, everyone? Alia, Anna, and Samira?
Yes, sir.
Okay, so I'm recommending you to please do the rest part of the theoretical preparation, and we will do question instead of the theory. That will be beneficial for us. And I would able to give you more and more question, and will be able to solve some question only if you will be able to do the theoretical part at home. Because if I'm directly going to give you questions, it won't be beneficial for you. Okay. So I'll see you
Okay.
in the next. I'll see you in the next class. You are going to do the ether part and phenol part, the preparation only. The chemical reaction I will handle it. Okay.